Welcome to Perfumery 101, where we'll be talking about the essential parts of perfumery. We won't be going in depth what perfumery is, but we'll be going enough to understand the main blocks of it. First, we'll need to talk about the concentrate, which is the main part of a perfume. It's the whole soul of it, the heart of it. Depending how much we put it into a perfume, will give us a separate outcome. Or fresh, an average of 1 to 3% of a concentrate. Then we have eau de cologne, which has from 3 to 5% of a concentrate. Then we have eau de toilette, which has from 5 to 15% of a concentrate. Then we have something stronger, eau de parfum, which has from 15 to 20% of a concentrate. Then at last we have parfum, or called extrait de parfum, which has from 20 to 40% of the concentrate. And depending how much the concentrate is the perfume, vastly change the smell of it and the longevity of it on your clothes or your skin. First of all, I'll show an example. It won't be a perfume, but it will be an accord, which is basically a glorified perfume anyway. And it has fewer materials than actual perfume would have. So the accord that we'll be using will be the Grossman accord. All in all, there are 4 materials here. I will later explain why dilutions are important, but for now, just wait a moment. So, we got Hedione, which is a 20% dilution, which has 2.5 grams. Then we got Isoe Super, which has 2 grams. Galaxolide has 3 grams. Alpha Somatol Ionone has 3 grams. So all in all, we have here 10.5 grams. Then we need to look at the relative part of an accord or a perfume. So there are 4 materials that we got. And to understand why we need to know the relative part of it is because when we look at the formula, we see what kind of materials they use and how much the average percentage of it is in there. Or on molecules, they show how much a material should be used on average or the maximum amount which is recommended. And that's why we'll look at the relative. When we add all of the materials, all of the grams that we got, always will be 100%. So if we were to calculate, we could take one example. So we take Hedione, which has 2.5 grams. And then we need to look at an absolute amount, which I'll explain a little bit further why it's important. And the other thing that I will have to explain is how it changes. Because depending on the dilution, we'll also get a different kind of an absolute, which is also known as how much of a raw material is in the finished product, which is the most important thing to look for the IFRA limits, so our perfumes would be safe to use. And to calculate the amount, we'll soon go into dilutions. When we take 2.5 and we multiply by 20%, we'll get 0.5 grams of raw material. And 0.5 grams of 10.5 is 4.76%. But if we add all of the absolutes, we will get 20%. Because to calculate the absolutes, we'll take a simple formula. So we take 0.5 and we divide it by the whole sum. And then we multiply by 100%. We get our 4.76%. Before going into dilutions, I wanted to mention that sometimes we get materials that are grams or sometimes that are milliliters. And we always in perfumery count everything in grams because not everything has the same volume. So the easiest way is just to count by grams. And the average difference is 1.25. So for example, if we have a 30 milliliter perfume, that will mean that it's actually 24 grams on average. It's not a formula set in stone, but most of the time it's like that. Now we will go into dilutions, which is to say that it might be one of the most important parts of perfumery. There are 2 main reasons why we make dilutions. Is that first of all, we will have control and precision over how much of raw material we want to actually put into it. Also, there are quite a few times where our raw material is not liquid. So sometimes we need to dilute it so we could work with them much easier. Some are actually resins, some are more powders. Of course, you can use powders, but some resins and very thick materials, it's much harder to use them in a precise way. From the previous graph, we will take an example for hedione. So we could make a 20% dilution of hedione. You need to have the raw material of hedione, or something that is higher than 20% in this case. So let's say we have 1 gram of hedione, which is raw. Our 20% of hedione, let's say we want to make 10 grams of hedione, 20%. And we got 1 gram of hedione, 100%. So it means of 20% of this, we got actually 5 grams. So we use dilution materials, of which one we have ethanol, which we write ETOH, means ethanol. We also have different kind of materials like DPG, IPM, DEC. All of them serve a different function, and sometimes you need to use specific ones so you could actually dilute the material. So let's say we take ethanol, and then the simple formula is this. And in this case, our desired solution is 20%, and the original is 100. And the quantity that we want, let's say, is 10 grams, simply due to simplicity. So the amount that we need here is 2 grams of raw material. So if we want to take our perfume's desired quantity, they have a recommendation. Then we minus our when we look at formulas, then our material solvent, which will be 8 grams of relative. If we want recommendation of how much of an code, then it will slightly change. When we look at the perfume, but not formula, then it will be 10%. We will get 1 gram. They show us what kind of relative gram, and then here we would have the percentage. But in this case, we got 8 grams. So from the raw material of 1 gram, we could make is 5 grams of diluted 20% material. But the simplest way let's say we want 1 gram, 10%. The easier way is just after the dot. We wanted 1%, so if we would go even let's say 10%. That is how much raw material is. 10% of 100 is 0.1. So if we wanted to make that's raw material, that we have 2 grams of raw material, 0.8 grams of ethanol, and we will get 1 gram of 20% material. And the other reason why we have very low percentages of dilutions is due that some materials are just that strong. Let's say because it's so strong that we need to dilute it further and further as much as we can. So the average use of it is, let's say, 0.1% or 1%. We just basically need a drop in the ocean. It's very common in the perfume formula that 1% is used because we need just a very little tiny amount of it. And if we basically use 100% of it, we couldn't properly dose it because let's say saffron at 10%, even 0.2 grams is absolutely insane. Basically, we have much more control. If we use 1%, we have a much better chance not to make an error. And our precision is much more accurate because the most important thing in perfumery is accuracy. We have much more control over 2 grams than of 0.2 grams because it's the same 0.02 grams of raw material that we got. So now we have much more precision. 0.1% would give us 20 grams. Let's say we want to use 20 grams of a material. We want just to use like a drop of it. At this point, it would be much easier to calculate trace amounts. So we put a very, very tiny drop and then we'll get basically below 1% concentrate or even lower. And the actual reason why we're looking at how much raw material is in the perfume, because some materials, let's say like lemon essential oil, has a limit of 2%. So it means that in a perfume, all in all, you can have only 2% of the absolute. So let's say we are making 24 grams, and in 24 grams, we can have only we could only have not 48 grams of the raw material, because we basically just multiply 2% by 24. And the other reason why we have dilutions is so we would have precision. So let's say we use 10%. With 10%, we go up higher, we go 4.8 grams. And if we want 1%, it will basically be impossible to go over those, because we couldn't just have more material than this in there. So basically it would be just trace amounts at best. But the most simplest way to check everything is just to go to molecules. And let's say we go to our Grossman Accord. We have 20% everything. So let's say we want 10%. Our absolute amount will change now. Basically how much of concentrate we have. So we dropped by everything by 10%, the raw material would drop, and that's why our absolute, which signifies our raw material, would also drop. So basically to calculate everything, you can just use the formula up in here. You just write anything that you want, any material. Let's say you take acetylquinoline and just go, let's say 1%, and you put in, let's say 0.1 gram. The absolute will kill a little bit of the dilution. You will get not 20% anymore, because there's less raw material now. And relative also changes. You can also delete it, you can replace it, you can do whatever you want, and it will be much easier to deal with. So I just don't calculate it by hand anymore. I don't use Excel sheets. I just use molecules, because it's simply the easiest way to check everything. The only thing that I check is actually just the IFRA limits, which I can just calculate by my own. Or the website here just shows me how much there is, or is too much of it. Let's say we take a material which is limited, let's say lemon. It will show you if there is too much into it. Let's say there is no red, because the limit is 2%. So 10%, then you're not in the limit anymore. And just the most efficient way to do everything. We have 10% here. We will calculate it again. So here of raw material, we got 0.25. Here we got 0.2. Here we got 0.6. We got here 0.6. So all in all of raw materials, we have 1.65 raw. That is our concentrate. And from that, we calculate our relatives and absolutes. So here we 25 multiplied by 100, take is 10.5. And that's the way we calculate our absolute amount here, 2.38. We calculate the other one, 0.2 by 100, 10.5. Then we get here 1.9. And we do it the same for the other one. Then we got here 5.714, 5.714. And in the end, we get 1570. And then we can calculate our relative one. Now we calculate from the concentrate that we had. You take 0.25, you multiply by 100, and you divide by 165. And you do it for all of the other ones. And like that, we should have 100%. And that's the way you calculate relative and absolutes. Basically, you need to know the concentrate amounts, how much there is raw material in it, and how much there is overall material. These are the most important things. And that's how you look, by looking at the absolutes, you know how much material there is in the perfume. Like that, you know how much material you can use and not impact your health while overdosing materials that might be harmful. And for these reasons, we have a very simple thing. We can go just into molecules. I have my perfume here, which you can see the same maps that we got here. It's literally the same. we go, let's say 20%, the relatives will change. So will the absolutes. The absolutes here don't change because here they didn't. But if I change something of here, everything will change in the relative. And of course, because this is much bigger, this material will be, the whole amount of raw material in it is going to be much higher. Let's say we got 20%. The math changes again. Go 20, and then the math is the simplest. If all materials are on the same, the math becomes much simpler. So that's the main parts that you need to know about the perfume. And you easily check everything. If you were to take a lemon, and it will show how much material there is in it. I mean, the maximum amount that you can use. Say 1 gram here, if you wanted to use, it would be too much. That would be, you could burn your skin like that because it has molecules that are bad for you if they're over the certain limit. Limits are just to protect yourself. And those are the main parts that you need to understand. And there you can input all the materials that you got here. You go to the database and molecules. You can write any material. You find the material that you got, and then you add it to your materials. It's something quite easy to use. And you got your whole list of materials that you use. You can make formulas, and then you can change or add whatever you want. If we were to say, let's take Himmel's perfume, we would have all relatives and absolutes and how much there is ethanol in it and everything else. And then you can just see the whole perfume. It's much simpler to do than anything else. So yeah, I hope at least it explains something. Have fun with it.